All right, well today I just wanted to do a quick review of Unit 4. In Unit 4 you were studying about kinetics and nuclear chemistry. So let's go ahead and start a little bit with kinetics and reaction rates. So according to the collision model, we know that atoms are moving all the time. And so sometimes when they collide, if they have enough energy, they can combine to create compounds. And so not only that, they must also have the proper orientation. So just knowing that all atoms are constantly in motion, but the only time that they can bond with each other is when they have enough energy to collide together and also when they have proper orientation. The activation energy is the minimum energy required to transform our reactants into an activated complex, which will eventually become our product. And so the minimum energy required. So again, this is the minimum amount of energy that it takes in order for this reaction to take place. There are two types of reactions. There are exothermic and endothermic. Exo means out, endothermic means in. So exothermic is when heat leaves the reaction. So this is a type of reaction where there's a lot of heat given off. And you can see that the activation energy for these is actually small. It does not take a lot of activation energy for these types of reactions to take place. So you can see the energy of the reactants versus the energy of the products. So the energy of the reactants is greater than the energy of the products, so heat is given off as a part of the products. Endothermic is energy in, so this is the type of reaction that requires energy in order for it to take place. So you can see that the energy of the reactants is less than the energy of the products. So the activation energy is a lot greater. It takes a lot of energy for this reaction to take place, and heat is required for this reaction to take place. All right, so looking at this, which graph represents the exothermic reaction? So remembering that the energy of the reactants is greater than the energy of the product, so it has to be 2. And then of course, which one is endothermic? Remember that the energy of the reactants is less than the energy of the product, so it would have to be graph 1. All right, so reaction rates is just basically the amount of time that it takes for a reaction to take place. And these are represented stoichiometrically, so just basically it's tracking the amount of concentration over time. All right, so whenever a reaction takes place, whenever we have a chemical equation, we always just see the reactants and the products. But it's important to know that sometimes when reactions take place, there can also be intermediate products. So we don't always notice those, especially when we're just writing a chemical equation. But here's an example. This is actually a very complicated one, where you have this reaction giving off some kind of X, which can represent any element. And so you can see that it does a lot of different orientation until we finally get down here to the product. So just knowing that when reactions take place that we don't always see all of the intermediates, we just see the beginning, the reactants, and then we just see the end, the product. All right, so because there are a lot of different steps that there have to take place in order for a reaction to finish, the slowest step in that is known as the rate determining step. So if you think about a marathon, if I am biking, if I am racing, if I am climbing a mountain, and if I am doing another step, the slowest step is actually going to be the one that is most important to determining my overall speed of that marathon. And the same is also true in chemical reactions. So the slowest step in those intermediate steps is going to actually determine how fast the reaction takes place. All right, so there are a few different factors that can affect the rate of a reaction. The main 4 that you had studied about in Unit 4 are temperature, and just remembering that always increasing temperature always increases the rate of the reaction. Surface area, so increasing surface area also increases the rate of the reaction. Concentration, so increasing concentration will also increase the rate of the reaction. And then of course catalysts. Catalysts are those things that help the reaction take place but don't actually participate in the reaction. All right, so let's talk a little bit about catalysts. So again, a catalyst is some kind of a substance that's going to speed up the rate of a reaction. And it's actually not going to be a part of the products or the reactants because it's not used in the reaction. It just allows a place for the atoms or the compounds to get together to exchange their different elements. And so the way that a catalyst works is it actually lowers the activation energy. So it makes it so that it requires less energy to take place. Enzymes are biological catalysts, so this is what our body uses in order for reactions to take place. All right, so here's just a picture of basically if you add a catalyst, so this would be a normal reaction, and then you can see that if you add the catalyst, it actually lowers that activation energy. Again, here's a picture of an endothermic reaction, one without a catalyst, so you can see that's a large activation energy, versus with a catalyst where that lowers that activation energy. Same thing with exothermic as well. All right, so if you climbed a hill in the presence of a catalyst, would you speed up going up the hill? Would you slow it down? Would you climb a larger hill or climb a shorter hill? And the answer should be D. It would lower the hill that you're climbing. Because remember that catalysts lower the activation energy. All right, let's switch over and talk a little bit about radioactivity. And so in Unit 4, you learned about a special type of reaction known as a basically a nuclear reaction. So most of the reactions that we've talked about to this point are just atomic reactions where we have atoms that are reacting with each other. In a nuclear reaction, we have atoms that are breaking apart. And so we have the nucleus is changing, and so we can be adding protons to the nucleus, losing protons, and so on. And so in this type of reaction, we're actually changing the identity of the atom. So when we talk about radioactivity, there are actually three main types of radioactivity. There's alpha, beta, and gamma. While chemical reactions involve changes in the electrons surrounding the atom, remember that nuclear reactions involve changes in the nucleus. So again, the number of protons and neutrons are going to change. And actually, it's interesting because when you look at the periodic table and you start to look at the elements that are 90, atomic number 90 and above, these are the atoms that start to have a lot of instability because you have a lot of neutrons and protons in the nucleus, and so they start to give off particles. And so they do this in three main ways, again, through alpha decay, beta decay, or gamma decay. All right, so let's look at an alpha decay. So when an element gives off an alpha particle, they're going to be basically giving off a helium particle. So if you can remember, helium has 2 protons and it has 2 neutrons. And so basically an alpha particle is when an atom gives off 2 protons and 2 neutrons. And so it's going to be positively charged. And these are very heavy and they are very slow moving. And so these are not very dangerous. So when an atom gives off this type of a particle, your skin can protect you from this type of a particle. Now you can look at some of the reactions. You'll notice that the atom always decreases by 2. And so just remember that's because it's losing basically a helium atom out of it. So here's an example, radon. Radon has 88 protons and 226 protons and neutrons. So when it gives off an alpha particle, it's going to give off those 2 protons and then a total of 4 protons and neutrons together. All right, beta particles are basically just electrons. And so when an atom gives off a beta particle, it's basically just giving off an electron. And so it doesn't really affect the atomic mass, but it can affect the atomic number. And so here's an example, carbon-14, which is present in all living things. It actually decays into nitrogen-14, and so you can see that it gives off a beta particle. All right, gamma rays are just basically electromagnetic waves, so they really don't have any effect at all on the atomic mass or the atomic number. These are usually given off by highly radioactive materials such as uranium, thorium, plutonium. This is actually what the danger in nuclear energy and nuclear bombs is that this is a very high speed, high energy wave, and it can cause a lot of damage to living organisms. It can cause cancer, a lot of different problems. All right, so when we look at radioactivity, there's a lot of different ways that we can protect ourselves from radioactivity. But again, in order to protect yourself from alpha radiation, really it's just a thin sheet. Beta particles is a little bit thicker And then, of course, gamma, you would need about 5 feet of lead in order to protect yourself from that. All right, so a half-life is the measure of how long it takes for half of an original sample to decay into something else. And so when you hear that the earth is 1 billion years old or that an animal lived 10,000 years ago, how do we determine that? Well, scientists look at the elements that are in these different things and they look at how much of it has decayed, and then based on that they can come up with a time from that. So every element has its own half-life. Supposedly the half-life of uranium-238 is 4.5 billion years. Obviously we can't verify that perfectly, but as it decays at this point, that is what we estimate its half-life to be. And that's a pretty long half-life. Whereas if you look at polonium, it's 0.0018 seconds. So they can be very quick half-lives or they can be very slow half-lives. All right. Well, that was pretty much it for Unit 4. I hope this helped you just a little bit to review those concepts. If you do have any questions or you need any help, please don't hesitate to reach out. Thanks.